meeting has started.
So let's take a look at the first one here. We always start out with the number that's by itself, the -2. That is the y-intercept, and that's telling us that from the origin, we go down to, that's where this graph starts from, is right there. The second part we look at is the part that multiplies the x. 2/3 multiplies x here, that is our slope. And remember, the slope is always a rise over a run. So from this starting point that we established here, we rise 2 and we run 3. That gives us a second point on our line. And there's our line. The second equation here, we have the +1 that's by itself. So from the origin, from the center, we go up 1. It's going to be the starting point of this equation, the y-intercept of this equation. What multiplies x here is a -3/4. Now remember, the run is always left to right. The rise, positive or negative, goes with the rise. So this being a -3/4, we're going to go down 3 instead of up 3. So from this starting point, we go down 3, and then we run 4, giving us our second point. Now finally, this third one is a little tricky. We have the number that's by itself is the 2. It's a +2. So from the origin, from the center, we go up 2. That's where this graph is going to start. Now what's multiplying x? It looks like x is being subtracted, but we have to write that as a -1 times x. Then we have to turn it into a fraction for the slope, so we make it a -1/1. So what that means is from this starting point, we go down 1, and then we run 1. Puts us right there as the second point on our graph. If we need to keep going, if those 2 points are too close together, we can do it again. We can go down 1, run 1 again, and get another point. We can keep doing that as many times as we needed to. And there's our line. Well, as we saw at the end of class yesterday, it doesn't always work out quite so neatly. Sometimes we have to do some rearranging on our equation. We might have something like y + 3 equals -1/2 x + 2. Or 2y equals 3x - 4. Or even 3y + 1 equals 4 - 2x. I'm going to give you a few minutes, about 3 minutes here, to take a look at those and try to graph them, and then we'll go over them. So let's take a peek here. The first one, we have to get y by itself. Right now 3 is added to it, so we're going to subtract 3. Remember, when we add or subtract, we only have to do it to one piece on each side. When we add or subtract, we can only combine the other things that have the same name. So on the left side, we subtract the 3 to get rid of the 3, so we just have y. On the right side, we're going to take the 3 away from the positive 2 ones. So the negative 1/2 x does not change. We have a positive 2 minus 3 is a negative 1. So from the origin, we go down 1. That's where we're going to start this line. Negative 1/2 means we go down 1, we run 2. There's our second point right there. So there's our line. For number 2, y has been multiplied by 2, so we have to divide by 2 to get rid of it. Remember, when we multiply or divide, we do not need the same name. So we can multiply or divide every piece, every digit by that too. So on the left side, we've divided out the 2. We're left with just y. On the right side, we have to divide both the 3x and the negative 4 by the 2. Well, 3x divided by 2, remember, we're just going to treat that as a fraction. 3 divided by 2 is just 3 over 2, and the x stays there. Negative 4 divided by 2 is just a negative 2. So for that one, we're going to start at the negative 2. So that's where this line begins. And I have a slope of 3 over 2. So from that point, we rise 3, we run 2, and there's our second point. So our line goes through those. Like that. For number 3, we have to get y by itself. Y has been multiplied by 3, and then 1 has been added to it. We're going to start by subtracting 1 to get rid of the plus 1. On the other side, I'll subtract 1, 1 from the 4 ones. So on the left side, I have 3y equals 4 minus 1 is 3, and then I have the minus 2x yet. I have to get rid of the 3 yet. It's multiplying y, so I'm going to divide by it. Remember, when we divide every digit on the other side by 3. So 3 divided by 3 is just 1. Negative 2x divided by 3. Well, negative 2 divided by 3 is a negative 2 over 3, or negative 2/3 x. So we're going to start at positive 1 to graph there. And then it's a negative 2/3. So we're going to go down to run 3. There's my second point. My line goes through those points. Like that. Any questions on those 3? So the next step would be if x and y started out on the same side of the equation. Something like this. 3x plus 2y equals 4. Well, we need this to be in that form of y equals. So we have to get rid of the 3x and that 2 that's multiplying y. So y has been multiplied by 2, and then 3x has been added to it. To take it apart, I subtract the 3x first. This is why we did those literal equations here last week, with just variables and no numbers. So the 3x is gone. I have 2y there. equals 4 minus 3x is just 4 minus 3x. Does somebody have a question? Now we have to get rid of that 2. It's multiplying y, so we're going to divide by the 2. Remembering to divide the whole other side by 2 as well. So that 2 cancels out. We have y equals 4 divided by 2 is just 2. Negative 3x divided by 2 is negative 3 over 2x. So we go to graph this. We start at positive 2. That's what that's telling us to do. And then we have negative 3 halves times x. That's our slope. So from that point, we go down 3 for the negative 3. And we run 2. There's our second point. Our line goes through those 2 points. Like that. Well, let's look at one more similar to that. Two x minus 5y equals 5. So we're going to start off here getting rid of the 2x. Right, the 2x. That's gone. I have negative 5y equals 5 minus 2x. Now y is being multiplied by that negative 5, so I have to divide by the negative 5. Remember, when we divide every digit. So that negative 5 is gone on the left side, leaving us with y equals. On the right side, 5 divided by negative 5, which is a negative 1. Negative 2x divided by negative 5. Well, negative 2 divided by negative 5. Negative divided by a negative is a positive. 2 divided by 5 is just going to be 2 over 5. And then the x. So to graph this one, we start at negative 1, right there. From there we rise 2, and we run 5. Their second point. And there's our line. I'm going to have you guys try a couple here. I'll start out with 3x minus 2y equals 4. And then we'll also have you do 4x plus 3y equals 6. We'll go over those two in a couple of minutes. So for the first one here, 3x minus 2y equals 4. We have to get rid of the 3x and the minus 2. This was built, y was multiplied by negative 2, then the 3x was added. So we're going to subtract the 3x first. Again, remember when we add or subtract, we only have to add or subtract to one piece on each side. So that 3x is gone. We have negative 2y equals the 4 minus 3x is just going to be 4 minus 3x. Now we have to divide by the negative 2. So that negative 2 cancels out, leaving us with y. On the right side, 4 divided by negative 2 is negative 2. Negative 3x divided by negative 2. Well, again, a negative divided by a negative is a positive. 3 divided by 2 is just 3 over 2. We put the x on the end. So to graph this, we start at negative 2. Right there. And then we have 3 halves x. So 3 halves is our slope. So that means we go up 3. And we run 2. Like that. So the 4x plus 3y equals 6. Again, we're going to subtract the 4x. So that's gone. We have 3y equals 6 minus 4x is just going to be 6 minus 4x. Then we divide by the 3. So that's gone. Y equals 6 divided by 3 is 2. Negative 4x divided by 3. Well, negative 4 divided by 3 will be a negative 4 over 3. When the x is still there. So that means we're going to start at the positive 2. Right there. And from there, negative 4/3 means we go down 4 over 3. Get our second point. So our line goes through those points. That. But what if we have equations that look incomplete? They're just a little bit outside of our normal form of the equations we've been seeing. Like y equals 2/3 x. Well, what we have to do is we have to imagine what the missing pieces would be. For this, we picture it as being y equals 2/3 x plus 0. The y-intercept is a missing piece there. There isn't one given. So that plus 0 is telling us that we just go through 0, or the origin, on the graph. The 2/3 x, well, from there we go up 2, and we run 3. Get to our second point. So if there's no y-intercept given, the graph just goes through the origin. A little bit harder to imagine is this one, y equals 4. For that one, we're missing the slope and the x completely. So we picture it as being 0x. Y equals 4 plus 0x. So the 4 is saying we start at 4. So from the origin, we go up 4, and that's where this line starts. Well, 0x, we can think of that as a 0 over 1, which means we rise 0 and go over 1. Well, if we draw a line through that, that's just a flat line. Y equals a number is exactly that. It's just a flat line at that number. Y equals 4. We went up to 4. We drew a flat line through it. Well, now that we've seen y equals 4 and we've graphed it, x equals 3 might be a little less of a leap now. X equals 3 goes against all of our conventions for graphing pretty much. There is no y-intercept there. There is no slope. X equals 3. If y equals 4 is a flat line or horizontal line at 4, it makes sense that x equals 3 is a vertical line at 3. That. So now the question is, what are the slopes of each of these lines? Well, the first one here is relatively obvious. It's still 2/3 times x. That has a slope of 2/3. It's the other two that's a little less obvious. For y equals 4, we had those 2 points. We rose 0 and we ran 1. That was a slope of 0 over 1, which reduces to just 0. So that flat line has 0 slope, or a slope of 0. X equals 3 is trickier yet. If I pick 2 points on that line, like this, I would say that's a rise of 1, but of run is 0. Rise over run, 1 over 0. That, if I tried to punch it in the calculator, would give me an error. It's what we call undefined slope. The slope of that line does not exist or is not defined. Now, here's the way I always remember those. I might have a touch of a twisted sense of humor. So if I have a line that's something like this, I think in terms of downhill skiing. If I am downhill skiing on that slope, that's a little bit of fun. It's a small slope. Relatively low slope. I'm on a slope like this. Obviously, at my current age, I'm probably looking for a helicopter ride. But in my younger days, that would have been a larger slope. A little bit steeper hill, more fun. A line like this, however, so skiing that, well, now it's kind of attractive to me. I do a little cross-country skiing, but that is 0 slope, or 0 fun for downhill skiing. And then, of course, if I have a hill that looks like this, and I try to ski down that, I no longer exist. I would cease to be defined. So for right now, I want you guys to work on graphing in the big book. Page 469, exercise 16-6. Page 471, exercise 16-7A, and page 472, exercise 16-7B. Looking at more graphing lines using slope and y-intercept. So I'll give you guys the last 16, 17 minutes here to get started on that. I'll be on the network here to answer questions if you need me to.